This is number 2 on the 2024 AP Pre-Calculus free response question set. Okay, so this guy requires a calculator, and you only really need it on two parts of the problem. So otherwise, it's very conceptual. All right, so this guy says on the initial day of sales, t equals 0 for a new video game, there were 40,000 units of the game sold that day. 91 days later, t equals 91, there were 76,000 units of the game sold that day. Number of units of the video game sold on a given day can be modeled by G. G is A plus B ln of t plus 1, where G is the number of units sold in thousands on day t since the initial day of sales. Use the given data to write two equations that can be used to find the values for constants A and B in the expression for G, and then find the values of A and B as decimal approximations. Okay, so we got to use the t equals 0, there were 40. T equals 91, there were 76. We got to use these 2 points to our advantage, which I wrote as G of 0 is 40, G of 91 is 76. So we plug in the t, meaning what's inside the parentheses, and then G of t, which is the output, into the model here. So that's why I did over here. Here are 2 equations. That's part 1. Part 2, you can simplify the first equation. ln of 1 is 0, so this whole term would go away. So A equals 40. And then the second part, you need the calculator. So 76 is equal to 40. That's what we found from the previous equation, plus B ln of 92. So B is equal to 7.96145. Okay, now this one says use the given data to find the average rate of change of number of units of the video game sold in thousands per day from t equals 0 to t equals 91 days. Express your answer as a decimal approximation. Show the computations that lead to your answer. Average rate of change is always like this. Change it y or we change it x within the 2 endpoints. So it's 76 minus 40 over 91. So that's 0.3956 thousand units per day. I would put the units. Even though it doesn't, yeah, I would just put the units just in case. So it always doesn't hurt to put units. Okay, this one, you got to be careful here. Use the average rate of change found in 1 to estimate the number of units of the video game sold in thousands on day t equals 50. Show the work that leads to your answer. So I feel like the common mistake will be people just put 0.3956 times 50. That's not the answer. It's 40 plus 0.3956 times 50. So I even modeled it in this graph over here. So if you start from 40,000 units, like the problem gave right there, at t equals 0. And you use this 0.3956 as your slope. So that's this line right here. Okay, at t equals 50, actually it's t equals 50 here, it's almost 60, right? So just by the model. So if you just do 50 times 0.3956, that's not even close to 60. Okay, so what's the problem? You have to add the initial value of 40. Okay, this is just the 0.3956 is the rate of change. That's the slope. That's not the quantity. Okay, so part 3, this part is very conceptual. Well, I think it is. So if you get the concept of concavity, then you got it down. So this says let A of t represent the estimate of the number of units of the video game sold in thousands using the average rate of change found in 1. For A sub 50 found in 2, it can be shown that A sub 50 is less than G of 50. Explain why, in general, A sub t less than G of t for all t where t is between 0 and 91. Okay, so basically this is saying this is the estimate, this is the actual, the G is the actual. The estimate is always under. Why is that? Well, you can even see from the model that I drew here. So you could use the graphing calculator to help visualize. That's why I put it here, but you don't really need it. This is how it looks. And as you can see, your A, which is this line, is always under G from 0 to 91. Okay, so we have to explain why though. It's precisely because this natural log is concave down, which means, as I said here, the rate of change of the units sold is decreasing over time. Okay, therefore the average rate of change will be under approximation. Okay, if it's concave down, like this curve, and you draw a secant line between 2 points is always going to be underneath, even if it's flipped the other way. I just imagine my laser pointer here is imagine like drawing another curve. This is also a concave down curve. If you just draw 2 points, it's again under the actual curve. So whenever it's concave down, the average rate of change is going to be an under approximation. So the key here was concave down, in my opinion. So I don't have the scoring guidelines, so I don't know how they score and what they're exactly expecting, but this is how to think of the problem. And then part C, the makers of the video game report that the daily sales of the video game decreased each day after t equals 91. Explain why the error in the model G increases after t equals 91. Well, this is testing if you know the shape of the natural log. Again, you have the graph, since you can use your graphing calculator, but if you just also know the shape of the natural log curve, you can answer this question also. The natural logarithm curve, or function, I should even say, let me go modify that. Where is my mouse? Natural logarithm, or I should say, natural logarithm function keeps increasing as t increases. And then I don't know if this part is required, meaning limit as t approaches infinity, g of t is equal to infinity. Again, I don't know if this is required, but I feel like the College Board likes limits. So I wrote that down. Therefore, if the sales decreased after t equals 91, the error would increase precisely because the function will keep increasing, but your actual points are decreasing. So the gap would be getting bigger. Okay. And that's it for this problem. It was not too bad. Some conceptual understanding of like this one, how the natural log looks, and then of this one over here, concavity. Otherwise, it's pretty simple.